Good evening, everyone. Today's session is on number system. We will be discussing about how we convert the decimal to base form and how we convert to an octal number, how to convert the hexadecimal number. So in this session, we will be talking about uh, on numbers and the manipulations, like how we manipulate it, how we calculate it, right? So what are learning objectives of this session? It would be in this chapter we will be learning about non-positional number system, and we are talking about positional number system first of all, and then after under this only we will be talking about decimal number system and binary number system, right? So let us begin with the session. So first of all, whenever we are going to start with any method, we need to convert a number to a base form. Now what is that base form? We will be converting into a decimal base, and then normally what we do is we have a form and we have a base, and we can convert it into decimal base and then decimal to some other base. So this is how a process continues, right? Or we can use some shortcut methods. What are those for conversions? Binary to octal number, octal to binary number, then binary to hexadecimal number, and hexadecimal to binary number, right? Then we have some fraction numbers also in binary system, but we will be discussing on the decimal number system first of all. So let us start with the first part. The first part basically talks about the non-positional number system. What are the characteristics of this particular part? We have the first part. If you want to represent any number, you may be taking it as a Roman calculation for that, right? So this is the Roman representation of 1, 2, 3, and so on, right? So basically non-positional number system talks about that. Each symbol represents the same value regardless of its position in the number. So we are not it does not matter what is the position of the number, we are just representing it, right, with the same value as well. The symbols are simply added to find out the value of a particular number. So we just add those Roman numbers, those numbers, to get out the particular number, to find out the value. And it is very difficult to perform arithmetic operations with such number system, because you have a representation style is would be like this, how to basically manipulate on these numbers. So it would be difficult task. So what we are going to do is, for that case, like, we can have a positional number system, right? Uses only few symbols called digits. So we will be using some digits in our number system in this, and these symbols represent different values depending on the position they occupy in the number. So basically based on the position they occupy on the particular number, right, that digit needs to be multiplied. Like if you are having the base 2, if you are having the base 10, if you are having the base octal, if you are having the base some other thing. So this is how it is calculated. So the value of each digit is determined by what? The digit. So there are three important things when we are talking about the value of a digit. What are those? The value of each digit, the digit itself, the position where it is coming, and the base number system. What method, which method you are going to implement. So this is very important point in terms of, like, whenever you are calculating, whenever you are applying any of the number system, right? So your base would be total number of digits in the number system. That is your base digit. That is your base number. The maximum value of a single digit is always equal to 1 less than the value of the base. So what is the maximum value for a single digit? That is always equal, or you may say it is always equal to 1 less than what is your base, right? What is the value of your base? Now here we can have some characteristics. We are starting with decimal number system, and let us understand what are the characteristics of decimal number system. A positional number system, because we can identify the position of any digit. Second, has tens symbol of digits, like it is starting with 0 to 9. So hence its base is 10. What is the base form you are going to take? That is 10. So you can have maximum of how many values in a single digits? Like suppose I am taking 1 0 2 4. So 4 has how many options? It is lying from 0 to, if this position is answered, I'm going to have a variations of number between 0 to 9. So a single digit, one less than 9, one less than the base value is taken out. Each position of a digit represents a specific power of the base 10. So this is a very much important point, because how to use it we will be checking in a numerical. We use this number system in our day-to-day life. So let us see, let us take a number and let us convert it to the base form. So you have, first of all, you have the number, right? So you, what you do is you basically take this digit, that is the first digit, 2, right? Then you are starting with, first of all, this is 0, the position of this digit, 1 2 and 3. So in decimal point number you basically multiply it with 10 raised to the power the position of that particular digit, right? So we start from here. The position of this digit would be 1, would be 0, this digit would be 1, this 2, and so on. So this is how we calculate it. Like for the last digit, it's the whole number is 2 5 8 and 6, right? So for 6 we have, what is the formula for calculating it? 6 into the base form is, basically in decimal we use 10, right? And 10 to the power the position, that is 0, then plus the second number is at the first position, so 10 raised to the power into whatever the value of that, then plus 10 raised to the power 2, because this is 5 is 2, 5 into 10 raised to the power 2. Then we have plus 2 into 10 raised to the power 3, right? So this is how it is calculated. And then we just find out the, we perform the multiplications, and that is 10 into square, then 500. Then we basically what we do is we get the same number. So this is the basically representation of that particular number, right? How to have a decimal number system in our numerical. Next is we have binary number system, right? By binary, it is obviously, binary means only two digits, 0 or 1. Whereas in decimal we have how many options? We have 0 to 9. Our number ranges from 0 to 9. Suppose I am taking as 4, 5 and 6. So this 6 would be between 0 to 9, right? And this 5 would be, it has the multiple options also. It has again 0 to 9, and this 4 is also, you have between 0 to 9. So that's why we have taken less than base, we have taken the numbers limit, that is 10 less than equal to. So we have taken 0 to 9 which has 10. So that's why we have taken this. In the next number system, that is binary number system, in this we have two options only, has only two symbols of digits or digits, that is 0 or 1. Again this is under a positional number system. You can perform manipulations, you can perform arithmetic operations, whereas in this position is also referred, hence its form is 2, because we have only two options, 0 or 1. The maximum value of a single digit is 1 less than the value of the base. Again the same procedure, same rule will be applied here also. The maximum value of a digit would be, single digit is 1, right? Then we have each position of a digit represents a specific power of base of 2. Like here what we have done in this numerical, each power has the base of 10. So because we have how many options from 0 to 9, so here we have two options, right? So our base would be 2, that is 0 or 1. So like in none of the books it is written how to have 0 to 9 or why it is 10. so you have to be clear in this point. Like we have the symbols, 10 symbols for particular digit, right? That ranges from 0 to 9. So here we have how many options? Its base would be 10. Why? Because the number it ranges from 0 to 9. Here the base would be 2. Why? Because the symbols or digits ranges or it is only 0 or 1, right? Then each position of a digit represents a specific power of 2. Then the same procedure, the same formula is applied. Yes, this number system is used in computers also. Now let us see in this part. You have the number like this, because we have for each digit we have only two options. So that's why we, by checking the number, we can say it this is a binary number system, because each digit, each symbol has two options only, either it is 0 or it is 1. So the base would be treated as 2. Whereas in decimal point number, for each number like 4, 5, 6, for this value you have the range 0 to 9, right? For again for the next value you have the range 0 to 9, and for the next value, that's why its base is 10. So make sure by seeing the number you are able to check out the decimal number system, right? And its base would be 10. So this is how to write base, that is 10, that would be representing a decimal point number. And in case of binary number, you will find out here its base is 2. So each digit is having only two options, that is 0 or 1, right? Now let us solve this part also. So starting with the first digit, right, again from here, so our position would be 0. The same method, 1, then 2, then 3, and then 4. This is how it is calculated. So you have taken the base, that is 2, 2 to the power 0 into 1. Then you have taken another value, that is 2 to the power 1 into 0. Then again 2 to the power 2 into 1. So what we have done actually is 1, here is 1, and then you take it, if it is a 4 digit like 4, so that means the starting digit will be 0, right? So from here we are starting, if we are starting from the last side, so how to write it? 1 into 2 to the power 0, then again plus, then take the next part. This is how basically we calculate it. So 1 into 2 to the power 4, then plus 2, 0 obviously, 0 into something is 0, then plus 1 into 2 to the power 2, that is 2 to the 4, then you take it as 4, and then we have again 2 to the power, this should be plus sign, right? So this is how we calculate with the help of base 2, and we convert it into a binary decimal point number. Now you have the base 10. 10 is itself is representing that we have converted the binary number into a decimal number, right? Like in this, if we calculate it, we basically it is a representation, right? How to represent the decimal point number, right? And this is what we have done. We have taken a binary number system and answer would be coming in decimal point, right? In order to be specific about which number system we are referring to, it is a common practice to indicate that the base as a subscript. So what we do is, thus we write like this. So we have any kind of number, like you might be having 10101. If you write it here as 2, so you write as a subscript, means you write which number system you are following, right? Or it is equal to 21, right? So and the base is what? Decimal. So from the base itself you are able to identify which number system you are following, right? So it's very easy to identify from the number. Or if you know everything, like I had told you about how to have a decimal point number, how many digits are there, what is the range of there, how we can have the maximum part, how we can have the minimum part. Now let us understand what is a bit, because we have already understand what is, when we are talking about binary number system, we are talking about only two digits, that is 0 and 1. Now next thing we have is bit. Bit basically stands for binary digit. Everybody should know this thing. What do you mean by bit? Bit is stands for binary digit. A bit in computer terminology means either it is 0 or it is 1. A binary number system consisting of n bits is called n bit binary system. So if you have how many bits? If it is have n bits system, then you are going to call it as n bit number system. Now let us talk about octal number system, right? Here, this system is also have is categorized under positional number system. You can perform manipulation on it, right? So here octal means 8 symbols, 8 digits. Your range is from 0 to 7, and it should be, again, it should be less than 8, right? So the maximum value of a single digit is 7. You cannot have, like, whenever you have any digit, any number, that ranges from 7. Each position of a digit represents the specific power of 8 because its base is 8, right? Like suppose I am writing any number and its base is 8, that means I will be following a octal number system. And suppose if my number is like this, 10 base 2, so I will be using binary number system. If I am having like this 4 5 and I have the decimal number system, so I will be having the base 10. So by the base as a subscript, we can easily identify which number system we are following. Next thing, let us understand this octal part also, how it works. So basically each since there are only 8 digits, 3 bits, 2 to the power 3 is equal to 8, are sufficient to represent any octal number in binary form, right? So let us see how it works. So you have any number, its base is 8, right? Now what we are doing, the same method we are going to apply here also, right? So what we have done, this is treated as 0 position, this is 1, this is 2, and this is 3. What is our base? 8. 8 to the power 0 into 7 plus 8 to the power 1 into 5 plus 8 to the power 2 into 0 plus 8 to the power 4 into 2. So this is how we are going to calculate, right? So basically our number is like this: 2 0 5 and 7, right? And because it's a octal number, we have the options of only 8 digit. The base would be your 8, and the last digit is 7, so we have the first pointer here, 8 to the power 0, right? And then the next digit plus 8 to the power 1, 5 has the 1. Then next position 2, 8 to the power 2 into 0 plus 8 to the power 3 into 2. Then we get a decimal point number. So obviously 10 is representing the decimal point number, right? This is how we have converted the octal number into a decimal number, right? So this is basically how to have a number system. Let us complete the last one also, that is hexadecimal number system. So this hexadecimal number system, basically it is again a positional number system, right? We don't have a non-positional kind of thing, and we can perform operations on it. Has total 16 symbols or digits, right? That ranges from 0 to 9, and then from A to F for representation of any digit. So we can have the value in an hexadecimal number that ranges from 0 to 9 or from A to F. So basically A means 10, B means, like here it is written, A means 10, B means 11, C means 12, D means 13, E means 14, and F means 15. Right? So basically your values would be between 0 to 15, and hexadecimal always represent the base, that is 16 symbols or 16 digits. Right? What are those digits? It ranges from 0 to 9 and A to F. Its base is 16. Right? The symbols would be A, B, C, D in capital letters. We usually write it, and it represents the decimal values of A. A is going to represent the decimal value of 10. B is representing the decimal value of 11. C would be 13, 12. D would be 13. E would be 14, and F would be 15. Right? The maximum value of a single digit is 15. Obviously, it ranges from 0 to 9 or A to F. So if we take any number, it ranges from 0 to 9 or A to F. Each position of digit represents a specific power base of 16. So I have already explained you the base power of this is 16. Right? Since there are only 16 digits, it has 2 to the power 4 are sufficient to represent any hexadecimal number in binary form. So here, like you have this number, so you can identify easily AF would be coming under the number system, that is hexadecimal. So its base would be 16. Right? I have already told you, like if we have any number 1, A, B, and like this. So this number maybe ranges from A to 0 to 9 and A to, yes. So this is how basically it is represented in hexadecimal form. Now let us convert it to a decimal form. So here we have 1, here we have A, here we have F. So first of all, again the same system would be followed, same formula 0, 1 and 2. Right? So here is F, here is we have A, and here we have 1. Right? So because it's a hexadecimal number and we are following 16. This thing, everybody should follow this thing. The maximum value of a single digit would be 50, because the last alphabet would be F. Right? So here we have 1 A F. Right? So and F is representing what? So we should understand this thing, like if we are talking about A is starting with which value? That is 10. Then we are taking with B. B is basically 11. Then C. C is 12. Then D. D is representing 13. E. E is representing 14. Right? And then F. F is representing 15. So before applying the decimal procedure, we should understand, we should write these codes on like in a rough work kind of thing, so that when you are converting into a formula you can easily apply that part. So 16, because it's a hexadecimal number, 16 raised to the power 0 because it is at the first position from right hand side. And then F. F is representing what? F is representing 15. So here you have taken 15. Very important point, because most of the students get confused why it is having A, why it is having E, why it is having F. We are not multiplying with like F1 or 16A or 16B. No, we are not following this part. Basically these numbers are starting with from 10, as in your uh, last number system. Right? So you have F F is representing 15, and then 16 raised to the power 1, and A is represented as 10. So you have multiplied 10 into 16 raised to the power 1, that is 16 itself. Then we have again a number itself. So number mein to no problem. We are directly multiplying it with the value, that is 2. Why the position is 2? Because here we have 0 position, here we are starting with 1, and here we have 2. So 16 raised to the power 2 into 1, and then we add all the things, right? First of all we multiply, right? The same formula we are going to use, and then we add all these numbers and get the decimal point number. Again, this would be converted into a decimal point number. So this is how we can convert a decimal number to binary number to decimal number. I will be telling you, like, whenever we have to perform any other method, like this is a very shortcut method, we usually follow this method directly. Using the, if we are using the hexadecimal, we are just taking the base of 16. If we are talking about the octal, we are taking the base of 8 and then multiply with all the numbers. But the only, you should remember this formula while applying this, because most of the student get confused and they write this 2 position at 0, so they multiply with 8 0. No, it follows from here right to left. So here from right to left is 7. So 7 into whatever the base is. It could be 2, it could be 10, it could be 8, it could be your hexadecimal form, that is 16, right? It could be any of the base, right? The formula would remain same. You are starting from right to left, and the first digit will be 0. The first position would be 0. 8 to the power, whatever the base to the power, basically it's look like this, base to the power 0 from right hand side, right? And then whatever the number you have, like 1 into something, then plus, and then again, now you increase the base is 0, then 1, then 2, and then 3, and then so on, right? So this is how we are increasing it, right? And changing the base according to the number system. If it is octal, you will be using 8. If it is hexadecimal, we will be using 16. If it is binary, we will have the base only 2. If it is decimal, we will be using the base as 10, right? So the main points to be included is, whenever we are using hexadecimal, we have the option from 0 to 9, right? And from A to F, because it is the only number system which has some alphabets parts also. So how to complete it, how to basically perform computation, it is a very easy task, until and unless you have not remembered anything. Suppose you not remember anything, you know hexadecimal is a having the base 16, just apply that. But before applying that, you have the last number, that is 50. You have to remember always the maximum value for a particular digit would be 15. It could not be more than that. And 15 means F. 15 is representing F. So you need to convert it into its, yes, into its this part also. Because if you are not converting it, it is not going to be understood. So the decimal values for representing these symbols would be starting after your 9 value, right? 9, then A is representing the 10, then B 11. So till 15 you have the last number, right? 15, then 12, then 13, 14, 15. So just remember this part, hexadecimal has 16 values. The last would be your 15, because you are not using the 16 one. It should be less than equal to the last number, the maximum value, the base value. So the base value is 16, so we have to move till what? 15. If the base value is 10, we will be talking about 0 to 9. If the base value is 8, we will be talking about 0 to 7, right? We cannot go beyond that. So this is how we convert the numbers into decimal point numbers or decimal number systems, right? I will be talking about the fraction number, decimal point numbers also, how to convert that part. I will be giving more sessions on that, and I will be coming with some more examples, right? So hope you have understood how the number system is converting and what is the basic logic behind that, like how we have the base 2, how we have the base 10, how we have the base 8, right? So hope you have understood, hope you like the session. Thank you.